Hello there and welcome to this exciting course on speech and text processing. My name is Erika Varga. I'm an assistant professor in the Institute of Information Technology at the University of Miskolc, Hungary. My special field of interest is natural language processing, which is strongly related to the topic of this online course developed by my colleagues László Czap and Judith Pintér from the Department of Automation and Communication Technology. Advances in computing devices and information technology make it possible for us today to use speech in human-computer interactions, which is the most convenient way for us to communicate. The natural speech chain contains a speaker, a listener, and the channel between them. Automatic speech processing means that one of the participants in the speech chain is replaced by a machine. The device that can take up the role of the speaker is called a speech synthesizer. Basically, there are two types of speech synthesizers in use. One of them contains devices that can transform predefined text to speech. You can find them, for example, at railway stations, where the producer of the sound coming from the loudspeaker is in fact a speech synthesizer with a limited vocabulary. The other group of speech synthesizers includes text-to-speech converters that can transform free text to speech. These are used, for instance, in applications that read books aloud. Earlier, the sound generation in speech synthesizers was performed by machines. Consequently, it sounded artificial, but the resulting speech could be easily understood. Nowadays, speech synthesizers form speech by combining small parts of a human speaker's voice. Today's research in this field aims at improving the naturalness of the generated speech. In the case of sophisticated speech synthesizers, you don't even realize that it is not human speech. The abilities of speech synthesizers today are not restricted to imitating the speaker's voice. There are audio-visual speech synthesizers that can also simulate the articulation of the speaker by using a 3D model of the face. If this facial model is transparent, the motion of the tongue becomes visible. We use this feature in a system that teaches deaf children to speak. The device that can take up the role of the listener is called a speech recognizer. However, the role of the listener is twofold. The human listener not only hears the speaker, but also understands and acts according to what was heard. Speech recognizers today can process speech, but it is not yet realistic to expect a resulting action. The most advanced systems are still restricted in functionality to dictation. You can test these systems in web and smartphone applications. Unfortunately, the abilities of speech recognizers today are still not comparable with those of humans, but it is much faster and easier to correct the text provided by the speech recognizer than to type in the whole thing for yourself. In this course, you will get to know the basics of speech acoustics and phonetics, focusing on Hungarian, which is an agglutinating language which makes it harder to recognize than English. Also, you will get an introduction to the types of speech synthesizers and the methods of synthesis. Then we will show you how to program a speech recognizer that recognizes the Hungarian words for numbers, hopefully in a speaker-independent manner. We believe that you will find this course useful because the signal processing methods you will get to know are used not only in speech processing. They can also be applied for processing any types of signals like noise or vibration. On completion of this course, you will be able to use speech processing devices and also to build them into new applications. After you learn the steps of training a speech recognizer, you will be able to program a speech recognizer for your own purposes. I hope you are looking forward to starting the course. Remember that the results you will achieve are worth all the work you will put in. Enjoy the challenges.